What's up? What's up? It's your man, Jimmy Chan. So, I have another system of equations here, and it wants me to do elimination. But before I even do that, you guys see this problem right here, right, that we're having, and that is, oh no, there are fractions. I'm scared. All right, so, no big deal. We can take care of that very quickly, and here's how we go about doing it. I can write any fraction as, anything as a fraction by putting it over 1, right? So I'm going to bring the sisters in, and the sisters is triplets that complains to dad to talk about how all the other sisters are their favorites except for her. So she's going to say, and the dad goes, you know what? Maybe you're right. Maybe I bought the other sisters more things than I bought you. So why don't you go ahead and make a list of things that you don't have that they do, and I'll get it for you. So the question is, what do they have that she doesn't have? Well, what she realizes that the 1 doesn't really matter, because if I multiply by 1, if I multiply the bottom by 1, I got to multiply the top by 1, which is okay. Let's go ahead and say that she's missing 1, which is herself. So she's missing herself. All right. So let's go ahead and bring the sister over here, or that's the second sister. What do they have that I don't have? Well, she doesn't have a 4. Well, if I multiply the bottom by 4, I have to multiply the top by 4. All right. Now, let's look at the third sister. She's also going to ask herself, what do they have that I don't have? The only thing that she doesn't have is 1 as well. Great. So now the sisters are done. What I want to check on is to make sure that all my denominators have the same thing. 4 times 1, 4 times 1, and 4 times 1, which means that each of the denominators has 4. So, with that being said, my new equation here is going to be 1 times 3x. So that's going to be 3x plus 4 times y is going to equal 27 times 1. Which is 27. So there we go. So now what I can do is take this equation here and this equation right here and go ahead and deal with my elimination and substitution. My elimination, not substitution. No substitution for you, okay? So I need to decide what I want to eliminate, the x or the y. Well, let's go ahead and eliminate. I'm not sure. Now, does it matter what I eliminate? The answer is no. I'm going to go ahead and eliminate y. Okay, just because I feel like it. All right. So nice part about y is that 1 is already positive and 1 is already negative, right? But 6 and 4, I need those to be the same number, which I can make them both 12. So I'm going to go ahead and multiply the top one by a 2, while I multiply the bottom one by a 3. Okay, so the top one is going to give me what? It's going to give me a negative 10x minus 12y, and that's going to equal to a negative 78. And the bottom one is going to give me a 9x plus 12y is equal to 1 carry the 2, 81. Okay, so I can go ahead and add these two together, and I get negative x is going to equal to 3. So x must equal to -3. Now that I have x is equal to -3, I can put it back into one of the original equations. And since this equation right here was not messed around with or trying to be moved or trying to be lesser, and that's what I'm going to use, okay? So I don't want to use the other one because there's a bunch of fractions as well, so it becomes a kind of a pain in the butt, right? So I'm going to go ahead and plug this into here. So I'm going to have a -5 times that x, which is -3, minus 6y is equal to -39. So I have a 15 minus 6y equals -39. So I'm going to have a -6y is equal to -54. So my y is going to equal to +9. So I have my x and y, so my answer is going to be the point -3, 9, and that is going to be choice A. And there we go. Hello, box. Welcome back. There we go. All right, so let me go ahead and make it picture perfect. If you have any questions, let me know. See ya. Bye.